Okay, so yesterday we talked about solving rational equations by making the denominators the same instead of using cross multiplication. This is going to really help us today when we go on to solve slightly more complicated rational equations. Now, the ones that we're going to focus on today, all of the denominators will include monomials. So they'll just be one term. For example, if you look down here at number 1, we have a k or 3k. Now, before I get into the examples I've written down, I want to just show you, start off kind of how we did yesterday. So if I had a problem such as 5 over 7 plus x over 7 equals 6 over 7. Pause for a minute and see, could you figure out what x is? Well, in this case, because my denominators are all the same, I can really just focus on those numerators. So if I said, okay, 5 plus x equals 6, well, I know that 5 plus 1 equals 6, so that means x must equal 1. Likewise, if we had something like 2 over 3x plus x over 3x equals 5 over 3x. Well, again, the fact that those denominators are all the same means I can almost kind of disregard those for the time being and just focus on those numerators. So 2 plus x equals 5. Well, I know that 2 plus 3 is 5. So I end up with x equals 3. So our goal for today is going to be to make all the denominators the same so that we can focus on those numerators. And I have a few examples written here that we're going to work through. So in order to do so, we're really looking for the lowest common denominator. And when trying to find the lowest common denominator, we need a little bit of everything. So for example, if you look at number 1, in my denominators, I currently have a k. I also have a 3. Well, I want to try and make them all the same. So fortunately, all 3 of these fractions already have a k. But the first and the last do not have that 3. So I'm going to multiply this first expression by 3 over 3 and this last one by 3 over 3. Notice now all of my denominators have a 3 and they all have that k. So I can focus on those numerators. So I have 3 times k minus 1 plus 1 equals 1 times 3, which is 3. So I'm going to distribute this 3 here. So 3k minus 3 plus 1 equals 3. Combine like terms, so I have negative 3 and positive 1, which gives me negative 2. Add 2 to both sides, so I get 3k equals 5, and then divide by 3. So my final answer would be k equals 5 over 3. So again, once you get those denominators the same, the numerators should form a pretty simple linear equation to solve. We're going to go through a few more examples. So number 2, slightly more complicated. So we see here that we have an x, I also have this 3, and I have this 2. So my lowest common denominator, if I wrote this off to the side here, again, I need a little bit of everything. So I need a 3, I need a 2, and I need an x. Well, 3 times 2 is 6, so my lowest common denominator is going to be 6x. So I want to go through each fraction and see what do I need to multiply by to make it equal 6x. Well, this first one I have the x, but I don't have 6. So I'm going to multiply both numerator and denominator by 6. Now the second one, I currently have a 3, okay? So I know if I multiply by 2, that's 6. I also need an x. So I'm going to multiply both numerator and denominator by 2x. And then finally, that last fraction, I have 2x, so I just need to multiply by 3, and then it will give me 6x. So going through and simplifying here, 6 times 2 is 12, so I have 12 over 6x plus 2x over 6x equals 3 over 6x. My denominators are all the same. This looks good. So I focus on those numerators. So 12 plus 2x equals 3. Subtract 12 from both sides. So 2x equals negative 9. Divide by 2. So x equals negative 9 over 2 or negative 4.5. Okay, we're going to do 2 more examples here. So for number 3, I have 1 over 2k equals 1 minus 3 over k. The first thing I'm going to do here is I'm going to make this 1 a fraction by just writing over 1. That works in all situations. Then I look at those denominators. So it looks like I have both a 2 and a k that I need to deal with here. So 1 over 1, I'm going to multiply both numerator and denominator by 2k, because that's missing everything. And then here I just have this k, so I'm going to multiply numerator and denominator by 2. So simplifying here, cleaning it up, I get 1 over 2k. Whoa. Let's try that again. 1 over 2k equals 2k over 2k minus 3 times 2 is 6 over 2k. Be careful with that minus sign, okay? I need to make sure that I'm actually subtracting 6. So when I focus on those numerators, I get 1 equals 2k minus 6. So I'm going to add 6 to both sides. So 7 equals 2k, divide by 2, and k equals 7 halves, or 3.5. Okay, my final example for today, and then you'll have a Canvas quiz to work on, is number 4. So again, I want to find the lowest common denominator. I need to make all of those denominators the same. So I see an x squared in the first and the last fraction. But in the middle here, I only have this x. Well, to get x squared, it's just x times x. So if I multiply both numerator and denominator by x, I'll get x squared. I also see I have a 2 and a 4. Well, if I want to make them the same, if I multiply 2 times 2, I get 4. So I'm going to multiply this first fraction by 2 over 2, because then I get 2 times 2x squared, which is 4x squared. And this last one I'm going to multiply by 4 over 4. So let me clean this up here and show you what I have. So I have 2 over 4x squared plus x over 4x squared equals 4 over 4x squared. My denominators are all the same, so I can focus on those numerators. So we get 2 plus x equals 4, subtract 2, and x equals 2. So I hope those examples were good for today. I am going to ask you to do a few practice problems via a Canvas quiz, and then we'll add on just a little bit more tomorrow before our quiz on Friday.